This is Mr. Beck Does Your Homework, AP Physics, homework number 8.3, question number 2. It gives you Boltzmann constant and the universal gas constant, so that's Kb and that's R. It says if 1.3 moles of a gas is confined to a 7.8 liter vessel at a pressure of 7.5 atmospheres, what is the average kinetic energy of a gas molecule? Answer in units of joules. Well, I know that my average kinetic energy is going to be 3/2 times the Boltzmann constant times my Kelvin temperature. I also know that kBt, since PV equals little n big R and T, also PV equals big N times the Boltzmann constant times the temperature. I know that kBt is the same thing, NKBT is going to be the same thing as little n RT. I'm given number of moles. I know the universal gas constant. I know the temperature, I know the pressure in atmospheres, and I know the volume in liters. I could get to my temperature, plug my temperature in here, use the Boltzmann constant, and do 3/2. So I could definitely do it that way, using number of moles, the universal gas constant here, the pressure, turn that into pascals, and then turn my liters into a volume. I'm still going to do that liters in the atmosphere, so let's just do that. My volume is 7.8 liters. I know that there are 1,000 liters in a cubic meter. So if I have 7.8 liters, that's going to be the same as 0.0078 cubic meters. That's going to be my volume. My pressure is going to be 7.5 atmospheres. Well, 7.5 atmospheres, I know that there are 101,300 pascals in one atmosphere. So I know that one atmosphere is the same as 101,300 pascals. So I can multiply those through and atmospheres will go away, and that'll give me my pressure in pascals. So there's my pressure in pascals. There's my volume in cubic meters. And now I've got 1.3 moles. I know that since N equals 1.3 moles, if I'm going to use the Boltzmann constant here, then I'm going to need the number of molecules. So I'm going to have to multiply by 6.02 times 10 to the 23rd. But since I already have N, I could plug in N there, R of 8.31451, pressure of 100 of whatever this answer is, and my volume of whatever this is, and get my temperature. Once I had my temperature, I could do 3/2 Boltzmann constant times temperature, and that will give you your answer for the average kinetic energy of a molecule. But there is another way to do it. I see kBt here, I see kBt here, so it's going to be PV over N. So just one shortcut here would be that my average kinetic energy is going to be 3/2 of, if I do PV over N, that's going to be P times V over N. And I know that if N is 1.3 moles, I know that N is going to be my little n times Avogadro's number, which is 6.02 times 10 to the 23rd. So I could do 1.3 times Avogadro's number, and that will give me my big N. So I've got my pressure, my volume, my big N, my 3/2. That will also give me my average kinetic energy.